This video is on Chapter 11, using advanced mates. So just as a review, last week we learned bottom-up assembly, which is just placing existing parts and sub-assemblies into an assembly file. And then we position components and add assembly constraints called mates. We practice bottom-up assembly in lecture with the ball joint assembly example. So right here, this picture, we basically inserted these different components. Then we added concentric mates to align these balls right here to the center ball joints to the ball joint arms. Okay, and we learned how to move components as well, using the move components or just clicking and dragging. In the lab, you did the links assembly, so it should look like this, and you made a copy of a component by holding the control key and dragging. So if I wanted another link, I would just hold control and drag that part to make a copy. You learn how to differentiate the parent from the copies by changing the color. So this orange one was the parent, it's fixed, and then these gray ones are actually the children because, the copies from this one. You learned how to use selection filters, okay, to select what type of geometry you're trying to select in your mates. And the mates that we learned was the concentric mate to align the holes of the single link to the double link. We learned the width mate to align the single link inside the double link. So here's the single link and here's the double link. Okay, so to position this inside of this little gap right here, we use the width. And then we use coincident mate to insert this pin into the hole. This week, we are going to learn more mates, in particular the advanced and mechanical mates. The lecture will cover rack and pinion mates and limit and cam mates. We'll also test mates using motion study, so you can actually create a video showing the motion of an assembly. And then, just as a reminder, there are 3 different types of mates. Standard mates, which is what we had been using last module. And then advanced mates include limit, linear, path, profile, center, symmetry, and width mates. So we did use width mates. And then mechanical mates include all of these options, and we're going to look at the rack and pinion in this lecture. So here's the first exercise. We're doing 2 exercises. Okay. All right. And the first step to complete that is opening the example from Canvas. Okay, so it might not be module 9, just make sure it's chapter 11. Let's see here. So yeah, chapter 11, here's part 1 files and part 2 files. Make sure you open, or you click it, click open, okay, and then extract, and then browse. And then you can save it wherever you want. I already actually have this saved on my computer, so I'm just going to cancel out. But that's how you would do that. All right, and so I'm gonna open, let's see here. So we wanna go to the part 1 files, and I'm gonna do the assembly file, so rack and pinion mates. So this is what it should look like, okay? And then there are more instructions right here, but I am going to, let's see, move this over so you can see my screen, but I'm gonna follow the same instructions. Okay. So the next is to add a coincident mate, which will align the front planes of both of these components here. So we're going to go to mate. We are going to go, we're going to open our feature manager tree and click the front plane for both of these. So the front plane, and then I'm gonna collapse this part and expand that one and click the front plane for that one. And you can see now that both of the front planes are aligned, and it used the coincident mate, okay, automatically. So we're gonna click check. Then we are going to add parallel mates. This is going to allow us to position the starting position of the gear, but we're actually going to just use it to help us position, and then we're going to actually suppress this mate. So we are going to, again, the feature manager tree, we are going to do right plane. Okay, collapse that one. And then for the rack, we want the right plane. Okay, there we go. And make sure the parallel is on. Okay, so now these two planes are parallel, just to help us position. Okay. And then we are going to do the check mark again, expand the mates, okay, and we are actually going to suppress this one now. Okay, awesome. And then let's move the, sorry, I don't know why it's not zooming. Okay, and then we want to position this, so just use your, won't let me zoom for some reason, but make sure that they don't interfere. Okay, then I'm going to do Control-7 for isometric view. Now I'm going to add a mechanical mate. So I'm going to go to mate. I'm going to go down to mechanical. I'm going to click on the rack and pinion. Okay, so for the rack, we are going to select that edge right there. Okay, and then for the pinion, we're going to select this sketch right there. Okay, you should be able to see the sketch. And then we are going to scroll down over here and click reverse to actually allow it to go forward and backwards. And then we're going to click check. All right. And then we are going to test the mate. So we're going to click check again to finish that. And then if I move this, oh, these aren't aligned properly. Okay, so I'm going to go back here and I'm going to suppress that. And then I'm going to move this right there, so they're not interfering, and then go back here and click there and unsuppress. All right, so now, yes, when you do it, it does not interfere, and you can see you can go back and forth there. Right. Awesome. The next thing we're going to do is we are going to create linear motion, so the animation. So we'll animate the motion using a linear motor to drive the motion. So we're going to remain in this isometric view. We're going to click down here, Motion Study 1. Then we are going to click the motor. So click this right here, motor. Okay, it's not a rotary motor. We're going to use a linear actuator, so we'll pretend like this is connected to a linear actuator, moving it, back and forth. So linear actuator, because we want it to go this way, the motion. The component is going to be, let's see here, the edge of the rack. So we want it to go that way. We want we want this to move. Okay, essentially, that's what we're looking for. That to move, and then we want that to move, let's see here, down here, we want it to be constant speed, and we want it to be 50 millimeters per second. Then we're going to click OK. Then right next to this 5 times the speed, playback speed, you're going to click down, and these are different things that you can play. we're gonna pick this playback mode, okay? And that will allow us to animate start to end, end to start, and then repeat. So it's gonna go from start to end and then end to start, okay, and then keep going. And you can actually play around with these different modes as well to see the differences if you'd like. Then we'll push play. And you can see that we have this animated video of the motion. We're gonna hit stop. All right. So that is exercise 1. I'm gonna exit out of that. This is actually exercise 2, but I'm gonna reopen it. So let me put this exercise 2 back up. All right. Now we are going to learn, use our exercise 2 example to add limit mates and cam mates. Okay, so this is the example we're going to use. The limit mate allows the component to move within a specified distance of angle. So if you look at this piece right here, this part, you can see that's only going from this angle here to this angle. It's moving at 90 degrees. So it can't actually flip all the way over to 180 degrees. And then the cam mate will allow this pin right here to follow this slot right here. Okay, so basically this will be coincident or tangent where a cylinder can be mated to a series of tangent extruded faces. So here's our tangent extruded face right here. Okay. All right, so you'll open the part files. Hold on 1 second. Okay, we'll open the part files, exercise 2. Okay, and then we're gonna do this assembly cam and limit mate assembly file. So I'm gonna follow these instructions again. All right, the first thing we're gonna do is add a width mate to align the components. We want this to be inside of this. So we'll go to mate. We'll go down to advanced mates, go to width. All right, and then we are going to select those 2 faces and then these 2 faces. All right, and then click check. So now if I move this, okay, great, it worked. And then we are going to add a cam mate, which is going to be under the mechanical mate. So just click mechanical mate to expand the different options for mechanical mate. And then this mechanical mate is going to force this pin in here, okay, in the slot, and move along this tangent face right there. So this cylinder will move along that tangent face. So we're gonna go to cam. You can also use the slot mate in this situation, but we're gonna use cam, okay? And for the cam path, the path is going to be, can't zoom for some reason, that face there. I can click on it because my computer won't zoom for some reason. Okay, let's try this cam follower. Okay, I'm gonna exit out really quick and try this again. All right, mate, and we want to do a mechanical mate. We want to do cam. Scroll up, the path is going to be there, okay, and the follower is going to be this pin, okay. And then, I'm going to clear that and click on, I wonder if, no, I'm sorry. Okay, we want it to be there. Okay, awesome. And then we're gonna go down to make a line and then just click the different types of alignments so that we align, why is it this? Okay, let me exit out. I think my computer's being silly for some reason. Okay, we're gonna do mate. And then we're gonna go to mechanical mates, cam. The path is going to be right there. The follower is going to be this. Okay, great. And then we'll change the type of alignment to actually align the pin in there. Okay, there we go. And then we're gonna click check. And then we're gonna add a parallel mate. So go up, click standard. I'm just gonna click parallel, and we want this to be parallel with this. And that's just gonna help us with our next step. We're actually going to suppress this, but it just helps us align this so it's 0 degrees. We're gonna do check, okay, and then check again, and then go down to mates. And then we are going to suppress it, or else we're gonna over-define our assembly. All right, and then we have one more mate to add, and that is a limit mate, so that this can only go the 0 degrees or up 90 degrees, but we don't want it to go all the way. So see how it can go all the way that way? We don't want that. So right now mine's not aligned again, so I'm gonna unsuppress this. Okay. And then I'm going to suppress it. Okay. And then I'm going to add another mate. I'm going to go down to advanced mates, click on this angle. Okay, and then this is going to be 0 degrees. This is, oh, okay. This is going to be 90. Oh, and then up here we actually have to select, we want this to be this one and this one. So it's going to be the angle between these, that they share the same angle here, 0 and then 90. Okay, so 0, 90, 0. And then we are going to click check, check again. And then you can practice moving. Okay, see, so if I move it, it won't go past that 90 degree there. Okay, yeah. So you can go around and practice dragging with these different parts of your assembly.